All right, today's purpose is to get us familiar with some of the vocabulary and math involved with understanding ramps and how objects act on ramps. Let's get to the vocabulary. This is the angle of the ramp. How much is the incline? That angle is equal to this angle. So those two are the same thing. Now, what's the angle of difference here? Well, that's the difference between the force weight and the force normal. Force normal is the force that goes into the surface of the ramp. Force weight's still going to the surface of the planet, but force normal goes into the ramp, which means that we all know that the force it takes to move an object up a ramp is less. And that's why we use the ramp. It decreases the amount of force that we need to lift the object up. How much force is decreased by is right here. So force normal is less than force weight, and this is determined by this angle here of the ramp compared to the difference between the normal and the weight. Now, to find mathematically what the normal force is simply equal to force weight times cosine theta. Now, to find the angle, you have to take the height and put it over ramp length. Now, to make this equal our geometry knowledge would tell us that the height is opposite this angle. And then it would also say that the ramp is called the hypotenuse. So having an opposite and hypotenuse means that we have sine theta equal to opposite over hypotenuse. So in the little phrase SOHCAHTOA, this would be so. This is the so part, opposite over hypotenuse, or the height over the ramp length. Let's go to number 3. This should clarify things up. So in this drawing, the ramp length is 21, and the height of the ramp is 3. We've already been told that it's going to be the sine, opposite over the hypotenuse. Sine theta is equal to 3 over 21. But because we don't have an angle, it didn't say, hey, sine 15 will lead you to this. We don't know it, so we have to do the inverse sine. We don't have the angle, so we do the inverse sine to find the angle. Now, that means that we take our calculator and we find this button right here, second function. Oh, gotta turn it on first, that would help. So we go second function, sine button, 20, number 3, or 3 divided by 21. 3 divided by 21. It should look like that in your calculator. Enter. So I got 8.21. 8.21 is the angle of this ramp. Because of the ratio of here, it knows that it must be that angle to get that ratio. So that's half the battle. To find the normal force, we just discussed up here, normal force is equal to cosine, or force weight, times cosine the angle. Let's put that in the calculator. So we have the force weight is given to us at 80. 80 times cosine the angle of 8.2. Yeah. 79.2 newtons. They're saying that a ramp at a gentle incline of 8.21 is going to fill most of the weight of the object. You're not going to get a huge advantage using a gently sloped ramp. It's not going to make the force to take it up any easier, really. You're losing a newton, that's it. Hopefully all this makes sense. You can use this to answer probably 80% of the problems. I will have a second video coming along that'll give us a better idea on how to do the more difficult problems. Hope this helps. If it didn't, go ahead and tweet me or check out the other video.